Hello everyone, my name is Dr. Hemlata. Welcome to my channel. In this video, I will be showing you the nature of binomial distribution with varying parameter values. Parameters are n and p. We already know, right? What is n? N is the number of trials in the experiment. P is the probability of success. So here we will see, first we will see one by one uh, for the different values of the parameters, and then we will plot the diagrams, probability mass function, and then in the last we will merge all the probability mass functions diagrams in one, and then we will compare. Okay. So first case we are taking when the probability of success is 0.5 and the number of trials are 20. Okay, so how the probability mass function looks like. Okay, first we will do this. So here since we are doing the four cases, we are assigning all the probabilities, all the arguments in the different objects. Okay, to plot the probability we need the d binom function. This is used to find out the probabilities for each value of x, and these are the arguments needed for that. If you want to know more about the d binom function, you can watch my another video of binomial distribution, and there I have shown clearly how to find the various probabilities of binomial distribution using R, and what is the nature of binomial distribution with the increase of the number of experiments as well as the number of trials. Here we are taking the concept, here we are taking only the parameters with the varying parameters, how the binomial distribution behaves. Okay, so first case is the number of trials are 20 and the probability of success is 0.5, that is there are equal chances of getting success and failure in all the trials. Okay, so we are assigning this into size 1 and probability prob 1 and the values of x, that is x values 1. So x can take values from 0 to the size, that is 20, so 0 to 20. Then we will find out the probabilities using d binom function. We'll calculate the probabilities and then we will plot the x values on x-axis and the corresponding probabilities on y-axis. These are the arguments needed for the plot function. So what type of diagram we want length. Length size should be of 4. Main, this is the main title of the probability mass function. The diagram, this is the x-axis title, this is the y-axis title. So if I plot this, we will get this diagram. Okay, to get the more clarity we can use the grid lines, we can add the grid lines into that. Okay, and at the same time let us calculate the mean. Mean is the n into p. N is the number of trials, p is the probability of success, that is what we are getting, 10. Okay, now let us see how the diagram looks like. Okay, this is how the probability mass function of the binomial distribution looks like if the probability of success is 0.5 and the number of trials are 20. So we can see the distribution is more symmetric around mean. Mean is 10, maximum probability it is 10, and it is symmetric. The both side we can see the probabilities are equally distributed. Okay, so what we can conclude? The conclusion is when p is equal to 5.5, equal chance of getting success and failure, the binomial distribution is symmetric around mean. This is the case 1. Now let us come to the case 2, where we are taking probability of success that is more than 0.5. Okay, increased probability, and the number of trials are same. Okay, so since we are doing the different cases, we will assign these into the different objects. So size 2 is 20, probability 0.7, the values of x from 0 to 20, and then the probabilities and the corresponding plot. Okay, so if you see the plot with the grid lines, at the same time let us calculate the probability, that is coming 20 into 0.7 as 14. Okay, now we will see the diagram. This is the diagram came. Let us zoom this. Here it is, this is the diagram. So this diagram shows the mean was 14, right? So somewhere here this maximum probability is at mean, that is 4, 4, right, 14. Okay, and this says as we increase the probability of success from 0.5 to 0.7, distribution has become left skewed. Okay, left is most mass of the probabilities is left side of the distribution, left side of the mean. Okay, mean, most of the mass of the probabilities is towards the left of the mean. Okay, so it is left skewed. So this happened when we increase the probability and the number of trials were same. Okay, so what can we conclude? As the p moves from 0.5, moves away from 0.5, the distribution becomes skewed. When p is greater than 0.5, the distribution is left skewed, and with more probability mass on the left side of the mean. Okay, the same thing we had seen now, right? Now let us take the third case. Here we are taking p, the probability of success is less than 0.5 and the number of trials 20. We'll do the same thing. Let us do the same thing and see how the plot looks like. Okay, here in this case n is 20, p is 0.3, the mean is going to be 6. Now let us have a look on the diagram. Okay, here the diagram is this plot. So mean is 6, the maximum probability is at mean. Okay, probability of success, average number of probabilities of successes, average number of successes are 6, the probability is high, maximum on this. Okay, we saw then if we reduce the probability from 0.5 to 0.3, distribution became right skewed. Okay, so more mass of the probabilities is towards the right side of the mean. Okay, so distribution became rightly skewed. Next case, this conclusion I have written here. Okay, same thing what I told just now. Now let us take the fourth case. Okay, in this case we are taking the probability 0.5, equal chance of getting success and failure, and the number of trials we are increasing now. Now let us have a look how the distribution looks like. Okay, the mean when p is equal to 0.5 and n is equal to 20, the mean will become 25. Okay, now see the distribution. This is the distribution. So what we can conclude from this, mean is 25, so average number of successes is 25 and the probability of success is maximum at that point, x is equal to 25, and if the probability of success is 0.5 and the number of trials are 50, the distribution is more symmetric around its mean, right? Symmetric around mean. The same thing I have written here in the conclusion. You can see with an increase in the number of trials, the distribution becomes more concentrated around mean. This is how we can see how the distribution, binomial distribution behaves with various values of the parameters. Okay, now we can make one plot, we can make one graph of all these plots to make the comparison. Okay, so what we will do here, the fourth case, if we see the range of x is maximum, that is 50 among all the cases, right? So we will plot the case 4 first. So we will use plot function. So x values from the case 4, x4, x values 4, probabilities 4, corresponding probabilities. Color we will give blue, the line we want, the y limit x is sorry, the value of x, the value of y, the range of y values will be from minimum of all the probabilities from case 1 to case 4 to maximum of all the probabilities. Okay, so this is how we will be giving the range of y. And range of x, we have already taken x, the fourth case, that is maximum 0 to 50. Now the x-axis title is the number of success, y-axis title is probability. The main title of the graph is probability mass function of the binomial distribution. So if I plot this, let us see how it comes like that, blue color. Okay, now we will add all other cases. So lines, by using the lines function, we will use the case 1, x values 1 and the corresponding probabilities 1, will make it of black color. Okay, so diagram came here. Okay, merged to the previous diagram. Same thing we did for the second case. Okay, color red, it came here. Okay, third we can add with the green color, came here. Okay, now we can show the legend. These colors means what and what are the parameter values. So we'll use the lesson function. We want the lesson to the right side corner. Lessons, these are the cases we have taken with these colors, and this I will plot in the diagram here. So if I zoom this diagram, it will see how nicely, let me do this again. So I'll make this little large, and then I will run this again because it was not coming proper. I'm doing the same thing. Okay. Now I'll add the lessons. Now it is non-overlapping. Okay. We will see. This is how my diagram looks like. Okay. I have added the lessons. What we can conclude from that? The blue color shows if the probability of success is 0.5, number of trials are 50, the curve is symmetric around mean. Mean is 25 in this case. Okay. We can add the mean values also here with this. Okay. This I'll show you how. Then black color, when the probability of success is 0.5 and number of trials are 20. So black color. Okay. Here the probability, the mean is 10. Okay. Same thing we can plot when the probability increased. When the probability increased, that is 0.7 now and 20. So red color. So this is the mean. Okay, and this is little, we can see if the probability increases, it becomes left skewed. Okay, and the green color shows probability is less than 0.5, that is 0.3, and the number of trials are 20, it became right skewed. Okay, this is how we can see. Now we'll add the probabilities also to get more clarity. So for the case 4, what was the mean? Case 4 mean was 25, right? I will write mean is equal to 25, comma, close. Okay. Case 1, what was the mean? Case 1, we can see the mean is 10, right? 10. Case 2, we can calculate 14. Case 3, 6. So I'll add here. Case 1, 10. So mean is equal to 10. Case 2, mean is equal to 14. Case 3, mean is equal to 6. Okay, so I'll take it down here. Okay. So mean of case 4 was 25. Case 1 is 10. Case 2 is, let me check it again. Case 2 14. Case 3 6. Case 4. Okay, that's all. Okay, so I'll do this again and I will run this to get it the good picture. I'll add all the lines to this like that, and legends. It is again overlapping, so let me make it little this, and then I will run this again. No, I'll do this again. Okay, don't worry. I'll plot, I'll add the lines, and then legends. Okay, then I'll show you. I'll zoom it. You can further modify this. You can take this, make it little short. Okay, many options are available. So what we can see here is this is the case 4 where mean was the probability was 0.5, the number of trials were 50. So this was symmetric around mean 25, right? The black color shows probability is 10. Probability is 10, so it is symmetric around mean because probability was 0.5. So every time when the probability is 0.5, probability of success is 0.5, there are equal chances of getting success and failure, it will be symmetric around mean. Okay. Next is the red color. If the probability increases from 0.5 to 0.7, the mean is 0.14, it becomes it becomes left skewed. You can see the red color, mean is somewhere here 14, so the more of the probabilities are towards the left side of the mean. Okay, same thing we can see with the other case. When the probability is less than 0.5, that is 0.3, mean is 6, the distribution became right skewed. Okay, like that. This is how we can have the clear understanding of the binomial distribution. I hope you would have liked this video. If you like my video content, please like this video, share with others, subscribe my channel. Thanks for watching.